everyone, and welcome to this session on replicating production on your laptop using the magic of containers. My name is Grace Jansen, and I'm a developer advocate at IBM in the UK, and I'm really looking forward to sharing this presentation with you today. If I don't get around to any of your questions for any reason at all, or maybe you think of one later down the line, then feel free to connect with me on Twitter. My Twitter handle is there. It's at GraceJansen27. It's on the last slide as well in case you miss it. So let's get started. So why are we even bothering talking about tests? Why do we bother writing automated tests? Well, it's so that we have the confidence that our applications work the way we want them to. It's to make sure that we're doing what we intended. If we were all perfect developers, we'd just write code, we'd push it up, we'd deploy it immediately, probably into production on a Friday afternoon, and we wouldn't be getting calls at 2 a.m. for support. Unfortunately, the world doesn't work this way, and none of us are perfect all the time. So we need to write tests to make sure that we're confident in our applications. And there's loads of different types of testing that you can do. There tends to be this sort of pyramid structure where you can see the three sort of main types of testings that you might use within your own application. So there's unit tests, integration testing, and system or UI, or sometimes called end-to-end testing. So unit tests, you can see here, create the bulk of that pyramid at the bottom. And that's because generally, this is the ideal testing pyramid. So you'd have more unit tests than integration tests, more integration tests than system or end-to-end tests. Unit tests are typically sort of automated tests that tend to be written and run by software developers to ensure that sort of a section or a unit, hence the name, of an application meets its design and its sort of the behaviors that were intended for it. Then you've got integration testing. This is a level of software testing where individual units are combined together and tested as a group. The purpose of this level of testing really is to expose faults in that interaction between these integrated units. And then the last one you have is the system or UI testing. This is really testing the complete end-to-end experience of your application, so everything all together. And that tends to be much smaller in terms of the number of system tests that you do, just because it takes a lot of resources, a lot of time, energy, effort, because you're having to get everything up and running just as it would be in production for that type of testing. So this is sort of the ideal testing pyramid, how much time and how many of each tests you might spend on each of these types. However, in reality, what our pyramid actually ends up looking like is something like this. This is a more realistic testing pyramid. So we have lots of time for unit tests. As we're creating our code, if we're doing something like TDD, we're creating our tests as we write the code. And usually it's fairly easy for a developer to write and run these unit tests because they are focused on a particular unit of code. And then we get a bit more into the integration testing, not quite as much as we might like, but we do some integration testing. And if we have time, we might remember to go and do a system test or an end-to-end test. But the problem with this type of pyramid is that you get something like this. So if we were to just test our applications with unit tests, we'd get maybe a scenario like the picture you see on the right here. So in this picture, we've got 4 unit tests. The tap turns on, the tap turns off, the drain works, and the sink doesn't overflow. But actually, it's a bit of a rubbish sink. I can't even get my hands under to wash my hands. The water isn't flowing into the basin like it was intended. So actually, although the unit tests all pass, what should have been done is some integration or perhaps system testing to show actually there are still issues with this particular system working as a whole. And that's where we can start to use things like containers in these integration tests to try and create more effective production-like testing for our applications. So, testing with containers. What is the magic behind testing with containers? Well, containers are fantastic at enabling us to have these isolated development environments. They're extremely portable. They allow for things like pre-configured images to be available. They also enable really fast startup times of applications. And the nice thing is, especially for developers, you don't need to have so many prerequisites installed on your local machine. It also allows things like version control of dependencies and enables you to easily develop for the cloud and enables this true to production testing. Because if you think about it, the majority of us are utilizing containers in some form or another for our applications. So if we're using it when we put our applications into production, then surely we should be using it when we test them to make sure that we get this sort of production-like testing environment and to ensure we don't miss potential failures that might be occurring or error messages that our clients and customers then experience when we push that into production. And actually, it's these last 2 points that we're most interested in today, and we're going to focus on in terms of these advantages. So really getting that true to production testing. Why is this relevant? Why is it needed? Well, actually, this all fits back into the 12-factor app methodology. So if you've not come across this methodology before, well worth taking a look at. You can head to the website 12factorapp.net and you can find out more about it. It's essentially a methodology that lays out 12 different factors that are technology and language agnostic. And it's all about these behaviors or characteristics for creating cloud native applications. That's applications that can really thrive in the cloud. And one of those, factor 10, is dev prod parity. What does this mean and why is it relevant? So here's a definition of what dev prod parity means. So it's all about keeping the development, the staging, that might be QA, testing environments, and production environments as similar as possible. So it's all about creating this consistency across all the various environments you might be using for different purposes. And that's so that you can negate these really common issues that occur when we have differences between these environments. The time gap, so the amount of time it takes you to write a code change and to actually get that code change into production can cause issues. And there might be more changes in the code base or the tools between when you make the change. So there can be issues there. The personnel gap. This is all about, is it the same person writing the change locally, but perhaps a different ops guy actually going and deploying it? They might configure it differently, and that might lead to additional potential failures or inconsistencies between the environments. And the tools gap. You might be using one software stack locally in your own dev environment, for example, because maybe it's faster, maybe it's more convenient, but you might be using a more robust software stack in production. So it's to help basically negate as much as possible these potential issues that might create potential failure points down the line. So really, the 12-factor developer should really be resisting the urge to use things like different backing services, different tools between the development and production and testing environments so that we can keep this consistency. And that's to stop phrases like this. Well, it works on my machine. It should work on every machine. You should have an environment as similar as possible so that we aren't getting excuses like this. So actually, testing with containers can solve a lot of problems or potential issues that we might have had before when we weren't using containers and we were just testing locally. So for example, testing data access to databases, testing integration better between the various components if you're deploying them in different containers, for example. Automatic updating and version control, if you have complex setups on your local machine, and enabling those testing environments to be really portable so others can run exactly the same test as you really easily, so they should be able to get the same error messages, and you can then collaborate on coming up with solutions to them. So now that we're convinced by testing with containers, let's take a look at the tools available to help us. So Testcontainers, as the name suggests, is all about testing with containers. So Testcontainers is a Java library that provides really lightweight, throwaway instances of basically anything that can run in a Docker container. And it supports unit tests like JUnit, for example. So here's a basic sort of overview of the architecture of what happens in Testcontainers. As I said, it enables you to create integration tests that are really easy to set up and write and run, and it tests your app in the same way you'd be deploying in production using containers. These tests the great thing about these tests is that they are portable to any compatible implementation, and there are quite a few out there that you can utilize, so you are not limited by a specific vendor, which is fantastic. Within Testcontainers, there is something called Microshed testing. So what is Microshed testing? Well, it's essentially a type of test containers. So the Microshed testing framework allows for true to production integration tests on your local machine because it enables you as a developer to minimize the amount of test failures due to those differences. It utilizes the magic of containers, like we've been discussing, to be able to replicate your production environment without much setup, which is fantastic. And it works with many different Jakarta EE and microprofile runtimes, like, for example, OpenLiberty. And it also provides really great integration with applications using, so for example, Apache Kafka for messaging. So the way that Microshed testing works, so this is an open source framework that you can utilize. As I said, open source, and it also integrates with many open source like Jakarta EE, microprofile, OpenLiberty. So the way it works is it uses annotations. So fairly similar to those other projects I mentioned, which also use annotations. So here are some annotations that are sort of heavily utilized within this framework and that we're going to be utilizing in our live demo today. So the main annotations that you'll probably need to use if you're thinking about using Microshed testing is the @Microshed test annotation, the @container annotation, the @REST client annotation, and the test annotation. So the Microshed test annotation is basically required so that the build knows that this is a Microshed test. The @container annotation, which you can see slightly lower down in our code sample here, is required for us to be able to set up a container to actually run our tests inside. So kind of an important one considering the purpose of this testing. The @REST client annotation is actually needed to give us something to test against. So this type of testing is essentially a black box type of test. So essentially we're testing from the outside in, so we don't have any impact on the code itself. So in order to be able to do that, we need a REST client in place to be able to actually engage the application and basically run our tests. And then we have the last one, the @test annotation. And this is just essentially really similar to how you'd run a JUnit test. It's just each individual test uses that @test annotation. So it defines the tests that you're going to be running your application against. Now, one thing you might be thinking about here when it comes to Microshed testing is, okay, we're running a container to be able to test that part of our application or any test that we put inside of these classes. But what happens if I've got multiple classes? Does that mean I have to use multiple containers? What resources is that going to consume? How much time is that going to take? How much money is that going to cost? Well, actually, the great thing about Microshed testing is that you can actually use something called shareable configuration. So if multiple test classes share or can share the same container instances, obviously depending on configuration, etc., they can then offload their @container annotation. So that's the one that helped us set up that container to be able to test in. They can then offload that annotated field to a separate class and actually end up sharing a single container, but we're testing multiple test classes. So you don't necessarily have to have a container per test class. You can share them, thus sharing those resources, cost, money, energy, etc. So when it comes to Microshed testing, what can we use it with? Again, just like test containers, loads of different runtimes available for you to be able to implement your tests on, including OpenLiberty, which is our open source application server, which is what I'm going to be utilizing today in the live demo. So this demo is something that you can get your hands on. This is an interactive demo. For the purposes of this presentation, I'm just going to be going through the steps fairly quickly. So if you don't feel like you can keep up or you just want to watch, that's absolutely fine. I would suggest probably just watching and then perhaps coming back to this link after this session to check out some of the other labs that we have available, or even doing this lab yourself afterwards at your own pace. This link takes you to a workshop page. So there are other labs that are available that take a look at other considerations you might think of if you're creating cloud native applications like health, metrics, fault tolerance, etc. And they utilize other open source projects and technologies like MicroProfile. So feel free to check this out after this session and have a go yourself. The one we're going to be doing today is specifically focused on creating tests using containers using Microshed testing. So without further ado, I'm going to jump into this workshop, into this interactive demo utilizing our workshop page. So again, if you want the link afterwards, then I will try and put it into the chat, but it's also available in my slides. So switching over, this is the workshop page you'll first come to. And this workshop page, as I said, has multiple labs that you can take a look at. These are all based off the OpenLiberty guides that we've created. So if you've not seen the OpenLiberty guides, then head over to openliberty.io/guides. And that's where you'll find even more guides that you can take a look at and do yourself around various cloud native technologies, principles, and methodologies. So as I said, the one we're going to be doing today is this one here. It's the testing a microprofile or Jakarta EE application underneath the title, Automating True to Production Testing Using Containers. When you click on this, it will open our skills network environment. This is a sandbox environment that we've created using technologies like IBM Cloud, O2O, etc. So it's running in the cloud itself, and we've already got all the prerequisites set up for you. So it should be fairly easy to use. You'll need to sign in, but you can sign in with many different social logins, including Google, GitHub, LinkedIn, Twitter, etc. So there's lots of different types of sign-ins you can use. Once you've signed in, you'll be greeted with an environment like this. So actually, if I go back to the beginning, just so you can see, you'll be greeted with the name of the guide, so you'll know you're in the right guide this way. And on the left-hand side, you've got the instructions. On the right-hand side, you have the IDE. And on the bottom, you should have a terminal. Now, if a terminal doesn't appear for you, don't panic. You'll just need to go to this top bar here, select terminal, and a new one will appear at the bottom for you. So I'm just going to go back to my previous terminal. Now, when you first start up this guide or any of these labs, then you'll notice that you won't have anything within your Explorer view. That's because I've just skipped the first couple of steps just for time management. So I've already cloned the repo, and I've already opened one of the files that I know we're going to be editing here. So most of our guides are based around sort of fairly similar applications, and they tend to be fairly simple applications just to make it easy for you to get started with this technology and not have to worry about understanding the application first. You can just focus on what we're trying to teach you in each lab. So in this one, we're utilizing this guide called Guide Microshed Testing, and it's all open source. If you want to go and check it out on GitHub, feel free. So I've already cloned it. And what you can do in each of these labs is try before you start doing the instructions. So what we have is, you can see it here in the directory. We have a start directory, but we also have a finish directory. Inside that finish directory, that is the finished application. So that's what you should achieve after you've completed all the instructions in the lab. So if you want to have a go and try that out first, absolutely go for it. We're just going to skip that today in the interest of time. So let's keep going. Now, I've already gone into the start directory, you can see here, and I've already started Liberty in dev mode. So what that really means is that we have this sort of hot reload type of deployment. So what it means is that the server is essentially listening for any file changes, and it's able to automatically recompile and deploy our updates whenever we save a new change to a file or to a class. So we're able to run it by using the following command, so mvn liberty:dev. Now you'll know it's up and running when you see the message that it was Liberty is running in dev mode, which you'll see somewhere here. There it is. Liberty is running in dev mode. So we know that we're ready to get started editing the files, and that we'll automatically get those changes, recompiling and deploying as soon as we do them. What we can do in dev mode is, all we have to do to run the tests that we have within our application is to hit enter, which makes it nice and easy. So the great thing about dev mode is that it can be really great at testing any changes you make within development really quickly and efficiently. So you can see here that we only have one test. It didn't fail and it ran successfully. And I've actually got the test up here in the class for you to see. So we're just doing this sort of blank test of creating a person in this application. So now that we know that our test is running, that our application is up and ready to go, we can start creating the changes in order to create a Microshed test rather than just a test running locally like we have here. So to begin, we need to be importing the Microshed test annotation. And to do that, we need to annotate this person service it.java class with the @Microshed annotation. If you'll remember back to that presentation, it was the first annotation I showed. So we provide the code that you need here on the left-hand side. So all you have to do is copy and then select all within this file and paste. Now, please remember to save, because if you don't save, as you can see here, the changes won't be picked up by dev mode. So you can see that this has already picked up my changes. So all we've added here is this @Microshed test annotation, which lets our application know this is a Microshed test. And we've added the @container annotation. And that annotation allows us to essentially set up the application we need to be able to test our application inside of. You can get more information on the specifics behind the things we're adding to this code. So the fact that we're using this with app context root string method, which helps to indicate the base path of the application. And there's like some more description there around what the context root is and why we've chosen that, etc. We're also using the with readiness path string method, which indicates which path is polled by HTTP and helps to determine application readiness. So essentially, we want to make sure that our container is up and running before we then go ahead and run our tests, because otherwise, if it's not up and running, our tests are going to fail anyway. So we can test that by opening up a new terminal. So I've already got one open from when I showed you at the beginning, but if you don't, head to terminal, new terminal, it will open a new one for you. So in this, we're going to run a curl command to essentially check that the default application readiness check is working and that our application is up and ready to go. So if we run this, just again, you can copy and paste. So run this curl command. You can see here that the status of our application is up. So we're good to go. So make sure, again, that you're saving your changes to the person service IT class. And if you have already saved your changes, we can head back to the terminal that has our dev mode running, and we can just hit enter and our tests will run again. So you can see it's fairly quick and straightforward, nice and easy to get those tests running. And you can see here that actually this time round, we've got this message here. So we're starting a container to run this test instead of just running it locally. So you can see here, we've got a hollow application server running and that we were able to run this test, which is great. However, as I mentioned, this is a black box type of testing, which means we can't access the application internals, and instead our application needs to be exercised from the outside. So we actually need a HTTP REST client in order to do this. So we're going to add the @REST client annotation, which again was mentioned in my slides earlier. So to do this, I'm going to grab the code here, again, select it all, delete, paste, and save. And you can see here, this is the extra annotation we've added, that @REST client. And this essentially allows us to set up the REST client in order to actually create HTTP post requests to the application that's running, which then triggers the corresponding Java method in the application for us to actually test it. So now it's time for us to actually write our first test. So now that we've got all of the setup complete, we can now start by testing the basic create person. As you saw before, it was just a blank test. Now we're actually going to put in the test code for it. So we can again copy and paste what we have here into this file, into this class, save it, and you can see this is what we've added here. So essentially we are including the assert not null static method, and we're writing the test logic in the test create person method. Again, remember to check that you're saving all of your classes when you create any edits to it. And we can just hit enter again in dev mode to get those tests running. So as you can see here, what you should see is this message here that says info building REST client. So that shows us that we're now utilizing a REST client, here it is, to be able to access our application and invoke those Java methods. So now that we've created one test, let's go ahead and create some more inside our test class. So now we're going to add quite a few more tests, which again, we've set up for you already, so you don't need to worry about them too much. It's just to show you multiple tests all running within this one test class happening in a container environment. So we're testing basically the minimum size of name we can do, the minimum age we can add to people. We're testing that we can get a person's information, we can get all people stored within our system, and we can update someone's age. So remember to save, and we can click enter again to get those tests up and running. So again, you can see we're just starting one container. We're still using a REST service, a REST client, which you can see in our output here, and we were able to run 6 tests this time, all inside that same container. Now, obviously, you might not always want to be testing within dev mode, which is totally understandable. It's really helpful for local development, but it can be tedious to test against a running OpenLiberty server in, say, a non-development scenario like CI/CD pipelines. So for this reason, Microshed testing can start and stop the application runtime before and after the tests are run. This process is mostly sort of achieved by using Docker and Testcontainers. So in order to test this, we can do Control-C to get out of dev mode, and we can just run a Maven Verify command. So if we get that running now, it will take a bit more time just because running tests, obviously from a cold startup, takes a little bit longer than running tests from development mode because the application runtime needs time to start. But Obviously, tests that are run from a cold start get to use a clean instance on each run to ensure you have consistent results, so that can help. So we'll leave that a bit of time to get up and running. So the next thing is all about the shareable configuration class. So if you remember back from my slides, I mentioned, okay, what if you have multiple test containers or test classes all using the same configuration? And this is where you can really utilize shareable configuration classes. So if you want to take a look at that in your own time, then check out the rest of this lab where you'll get to see how you can utilize those shared configuration to use the same containers to be able to test multiple classes for your application. So heading back to the slides just to finish up. So in summary, containers are fantastic. They make developers' lives easier by enabling portability, configuration, and they're very lightweight. And they can help us solve some of the issues with testing like dev, test, prod parity. There are some fantastic open source tools available to utilize when testing with containers like Microshed testing and Testcontainers. And they help us speed up time to production, making everyone happier. So if you're interested in checking out more, then take a look at the additional resources I have here. We have a testing series, and I've linked to each of them open source projects I've mentioned. Thanks very much for listening. Hopefully you enjoyed this, and thank you for joining me. Hi, everyone. Thank you so much for joining my presentation. And now we're going to move on to just a quick Q&A sort of session now with me. If you haven't already put your questions in the chat, please do put your questions there now, and I'll try my best to get round to them. So I know we've got a couple of questions in the chat already. So thanks so much to the guys who have contributed those. So we've got one that says, how hard would it be to add a custom runtime? Now, obviously, in my presentation, I mentioned that in order to utilize things like the Microshed testing framework and the Testcontainers framework, you need to be using a compatible runtime implementation. There was a list that I put on the slides that are compatible with those frameworks. OpenLiberty is one of those among them, and that was the runtime that I was utilizing in the demo that you saw in that presentation. Now, in terms of adding your own custom runtime, I don't know necessarily how difficult that would be because you'd need to be able to integrate that as a compatible implementation of the frameworks. Maybe if you could give me some clarification on perhaps what you mean by that, whether you mean, say, the application runtime and whether it was on that list that I showed earlier that was the compatible runtime implementations you can use with either of those frameworks. Hopefully that sort of answers your question. If it doesn't, please feel free to add some clarification. We've got another second question, and that's how does Testcontainers compare to Arquillian? Now, I have to admit, I've not necessarily used Arquillian very much. Obviously, it's another Java testing framework. So I believe that the main benefits of Arquillian is that it handles things like the application server lifestyle for you. There are obviously container adapters when you're utilizing Arquillian and stuff. Again, I haven't used it that much, so I don't think I can necessarily directly compare the two. I would say that my opinion of Testcontainers is that it's fairly easy to run in terms of getting it up and running, as you saw, moving a JUnit test that runs locally into a container. If, for example, you're already using JUnit tests, for example, or other styles of unit tests, it can be quite easy to convert those up to a Microshed test just with a few annotations. But good question with Arquillian. I'll have to look into it a bit more and try out both to give you a full answer. Regarding the runtime question, different configurations of OSGI. Ooh, I'm not sure about that one, actually. I will get back to you and have a chat with some of the developers in my organization about that. I haven't tried it myself. We've just sort of been running with the default applications that I showed you within those demos. As I said, we try to use the same application for all of our labs, so same configuration, same runtime, etc. So I haven't given it a go with a different configuration. So I will try it out and get back to you. If you want to follow me on Twitter, I'll try and post the answer there. Or perhaps, depending on how in-depth I get, I might write a blog or something, and then I can post the link to that as well. But good question. Another question that we have, can Testcontainers be used to test JTA transaction? JTA standing for, if you could write that for me, that would be helpful. Java Transactions APIs. Good question. I'm afraid I don't know the answer, so I will look that one up for you. The only thing I would say in terms of a potential limitation of test containers that it is important to bear in mind if you are going to go ahead and use this is that at the moment there are some complications around trying to use things like test containers in a CI/CD pipeline. So using it in something like Jenkins or something means that you end up having to use a container within a container, and there are certain security risks that might come with that. You need to give that container full access and full security access. So there are some limitations in terms of using this kind of framework if you have that kind of automation within your application development pipeline. So that's something to bear in mind just if you are thinking about going forward with this in future. For all the questions I wasn't able to give detailed answers to, I will try and get back to you when I've gone away and had a look at them a bit more. And I will be posting those onto Twitter. So thanks very much for joining this session. I hope you enjoy the rest of EclipseCon. It's been lovely joining you. Thank you so much.